introduce you to Keith Peterman, an esteemed scientist and someone we're lucky to have on the panel. He's a member of the American Chemical Society Committee on Environmental Improvement. He's served as a Fulbright Scholar in Germany and Russia, National Academy of Sciences Scholar in Poland, a research fellow at the Naval Research Laboratory in Washington, D.C., and a visiting professor in China and New Zealand. His current pedagogical activities, research and writing, focus on issues related to climate change and sustainability. He takes a student group to Costa Rica each year to investigate climate change issues linked to impacts, adaptation, and mitigation. He writes a blog hosted by the York Daily Record Sunday News and is a contributing member of the Huffington Post blog team. He also, just on the side, participates in United Nations climate conferences as an accredited member of the press. So an impressive record, and to Dr.
Okay, well, thank you very much. It's nice to be here, and I appreciate everybody coming out. My role here today is to talk a little bit about the fundamental science, because when we say going to the DC and talk about politics, what's on clear display there is we're still in science denial in the U.S., about half the population. So I'm just going to try to pick up a snippet, and I think that some of you in this room will be able to relate, just as the story I'm going to start out with, which is going to go the whole way back to Sputnik. Some of you will remember it. For others, it will be a history lesson, but I was a 9-year-old boy when Sputnik was launched, and we had this, if you recall, the beep, 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 going overhead. The Russians were going to drop, or the Soviets were going to drop a nuclear missile on our head. We had drills as a kid. I remember we had to crawl under the chair. Instead of fire drill, you had the nuclear bomb drill. Peterman, get your head down, quit looking out the window, because if a bomb goes off out there, you're really in trouble. So anyway, that's our Sputnik very much started the space race, and I think we're aware of the images of mushroom clouds and the idea that backyard fallout cellars were being built and so forth. But actually, what Sputnik did was it overshadowed the International Geophysical Year. That actually was an 18-month year. It started in late 1957. Sputnik was a part of that, and the purpose was to study global geophysical activities. And because of the space race, there were a lot of developing new technologies that were coming on board. One of those was infrared spectroscopy, and as part of the International Geophysical Year, a young researcher by the name of Dave Keeling got some funding working through Scripps Institute. He was able to go and set up infrared analyzers on Mauna Loa Peak in Hawaii, and he got the first truly high accuracy, high precision measurements of carbon dioxide in the atmosphere. And he was well prepared to do that. He had done some work beforehand. He's become recognized as a foremost analytical chemist. This is the record. He started in 1957. And this record continues today. Dave Keeling died in 2005, but he got his first reading in 1958, actually, when he got his first reading, and the carbon dioxide atmospheric concentration was 313 parts per million. If you look at this graph here, you'll notice there's a seesaw pattern to it. The red line is actually the seasonal variation of the carbon dioxide going up and down with the seasons. The black line eliminates the seasons and it just shows the year-over-year increase. But what we find is from 313 parts per million, today it is 400 parts per million. In my lifetime alone, the carbon dioxide concentration has gone from 313 to 400. That's about a 28% increase just in my lifetime. I just created this graph and I'm making a prediction. And the prediction is that this year, for the first time ever, our monthly average for carbon dioxide, global average, will exceed 400 parts per million. It actually was reported last year that it tipped over, and there's a little bit of controversy about that. But in fact, if you go into the website, you'll be able to check and see that it's going to exceed 400 parts per million. But I'd like you just to look at the seasons, for example. If you look at October 2011 down here in the bottom, look at the numbers, 388.96 parts per million. That's 5 significance figures. That's a very high precision number. It's highly accurate. Scripps Institute and NOAA are getting exactly the same values using different techniques. If you follow October and count each month, October, November, December, January, February, March, April, May 2012, the carbon dioxide concentration is increasing. That's the winter months going into May. Well, we all know what's happening right now. Tomorrow is May 1st. We're a little bit slow this year, but we're beginning to see the leaves come out, the plants are growing, and they're beginning to sequester carbon dioxide out of the atmosphere. And during you start at May 2012, going through the summer, you can see May, June, July, August, September, October, bottoms out again, and that's when the carbon dioxide is taken out of the atmosphere. Well, what Dave Keeling did was he made an acute observation way back about 1962. He published the work the first time, and he said, what we can see are two things. Number one, planet Earth is breathing. And to me, that's probably one of the most profound things. We can actually see the carbon dioxide increasing and decreasing with each season quite dramatically, the impact of vegetation and so forth. The second thing is there's a year-over-year increase in the carbon dioxide. This is high precision, high accuracy data. I could look at a lot of things that are known with very high levels of scientific certainty. Basically, I shouldn't even be up here tonight because the science should not even be discussed anymore. If you hear the scientists speaking, they said, we know so much. I mean, the science is, we're way beyond that. And it's time, the purpose of this tonight is that the time now is to address it. But to address it, we have to get our policymakers engaged. I think you're all familiar with the IPCC assessment group reports that have come out. The three of them. The first one that came out was the IPCC Working Group 1. I think what's already been mentioned here is the CO2 concentrations are unprecedented in the last 800,000 years. They quote, the warming of the climate system is unequivocal. Scientists just don't make statements like that. That's a quote, it's unequivocal. Each of the last 3 decades is successively warmer than the preceding decade, and we can look at these for the graphs and so forth. We've seen the Greenland and Antarctic ice sheets losing mass, ocean acidification, sea level rise. I think these are all in the literature, but it's well documented and supported by the science. So beyond the light bulb, it's what do we do about it? And one of my goals, and the reason I do things like I have my blog site and try to do the writing and take students, the whole purpose of this is for climate change literacy and outreach. The American Chemical Society has a very, very strong climate policy statement, as does every single major scientific society and health organizations. They have very strong climate policy statements. Ours has 4 specific actions. One of those 4 actions is climate change literacy and education. Some of the things I do taking the students to the UN Climate Conference is related to that, and that's trying to get peers, speaking with peers, much like we're speaking with each other here this evening. So I do take ACS student representatives to the UN Global Climate Conference. And here's the sum of my comments for this evening about the science is, let's have public policy based upon science. Stop arguing the science. It's very, very clear. There just is not scientific literature out there, peer-reviewed literature that says that it's not occurring. It is, and let's get to the real heart of it and base public policy on the basis of science and not ideology. All right? Thank you.